Hey, this is a hopefully 5-minute video to show you how to get up and running with the default Donkey 2, and get started right now. Using this, this is my car, and it is the default Donkey with the exception of I've added the new sombrero hat, but this hat works the same as the default Donkey car setup. So on the left here is where I'm going to log into my car. And I called my car PyRed, so I can go SSH py@pyred.local. And I'm using a wired connection. This is connected to Ethernet, but this would also work on wireless. So now I'm into my PyRed camera, and this doesn't assume any special disk image, but it assumes that you've already activated your camera and I2C connection, but it doesn't have any software installed. So we're just going to follow the instructions of this Donkey 2 repo, and you can find it at autorope/donkey2, and it just has the scripts for driving and training. The most of the code still lives in these separate repos, which are the part repos and the donkey car repo, which is the core logic. So we're just going to install the drive requirements on the car and the training requirements on the computer and see how this works. So on the Pi, we're going to create a virtual environment using Python 3. So virtual in, we're going to name the environment in and use Python 3. Then we're going to activate the environment by running source and then the activate script. And there we go. So now we know we're in the environment because it will prepend in before our command. So next we're going to download this repo using git clone into a folder called Donkey2. And I'm going to go into that folder, and then we're going to install the requirements that are required to drive the car. So this will install everything into that virtual environment. It's going to take all the parts, take all the dependencies of the parts, including TensorFlow, and install it on the Pi. This will take probably 2 or 3 minutes. So while this is going, we're going to get set up on the on my computer, which is where I'll do the training. So I'm going to cd into my home directory. I'm going to just follow these instructions on how to train an autopilot, which is again to create a virtual environment, activate that virtual environment, and clone the same repo. Again, the right side of my screen over here is on my computer, which is what I'm working on now, and this left side is an SSH session on the actual Pi. So we're in Donkey 2, pip install the training requirements. So these are different because we can't and we don't want to install any of the Pi camera and any of the actuator parts because it'll error out. So this is the same as the drive requirements, except those requirements aren't needed. So we're going to install that. It's going to install the same version of TensorFlow, which is very important, and I think we're using 1.11, which is a constant source of confusion for people because you can train on TensorFlow 1.3 and then try to use it in TensorFlow 1.9 and it won't work. But assuming we're using the same version of TensorFlow, and if we follow this, they'll both be installed in the same version. So we're ready on the computer to run this once we have the tubs. So we're just waiting for TensorFlow essentially to install on the Pi. But TensorFlow has created these binaries for the ARM architecture, and so it is actually pretty quick. While we're waiting for this, the primary motivation for separating everything out into different parts is to allow people to pick and choose the parts they want to use, so that instead of just hard forking the donkey car repo, you can make incremental improvements on the parts that other people can use. So, for example, a popular branch is Ton Kramer's branch in San Diego, and he initially hard forked from Donkey because I made a silly change that made training really slow, and it's never been worth it for him to bring it back in to the major branch. But I'd love to have his contributions going to the main branch, which is what everyone uses at first. So I hopefully this is going to allow people to, instead of hard fork, just use the parts that they need to work. So I've moved everything into the auto rope organization. This is the repo we're using now, but you can see all of the parts that are available. It just is, it starts with anything that starts with a donkey part is a part. So here's a Bluetooth controller. What else? This is the PS3 controller that Ton wrote. This is the sombrero hat, which is what I'm using. So it lets you power the Pi from just the RC car battery. Here's the part for the actuator. Here's the autopilot we're using, a web controller, and a couple different simulators. But here you can just pull in the part that you need and use it. Here we're still waiting for this to install. What else? I can show. So inside the drive script, you'll see what used to be inside the manage.py script, and it just walks through how we're going to set up our vehicle by initializing each part and then adding them to the vehicle, and then eventually starting the car, which just starts this loop to update the state of the car continuously. Okay, we're installed over here. So we just should be able to run this Python manage.py script. Oh, that instruction is wrong because we are no longer calling it manage, we're calling it drive.py, and that should be it. It says we're using Donkey Car version 2.5.9, and we'll see if this works. If it does, we're going to quickly update these instructions. Looks like it does work. So here we're just running drive manage.py, and it changes. Now we can see that that is correct now. Oh, I see that this is wrong too. Okay, so our car is started, and we should be able to go to the name of our car, the same thing we used to SSH into the car, and it runs on port 8887/drive, and we can see that this car is now running, and we're just going to record a couple frames for an example, stop recording, and then we're going to stop the car, Control-C, and we'll see that this tub was created. Inside the tub there are 52 records of the frames that we collected. So then to get that data over to our computer, I'm just going to make a directory to put the tubs, and then I'm going to use SCP to pyred to get the car, get the data from the car to the computer. So I'm just specifying where the tub is, and oops, it's got to be recursive to get, because it's a directory. So -R as an option, and then we're going to put it in this directory test tubs in a folder called tub1. So now if we look inside test tubs, we have a directory called tub1. So now we're ready to train. So the script should be, it's not manage.py, it's Python train.py, and then test tubs, and we want to train on all the tubs in the test tubs. So we use the asterisk to specify that everything in the tub is a tub that we want to train on. So then it's going to train. And while this is training, I'm going to update these instructions. And so this is not manage.py, but train.py. All right. Okay, so we're using a trivial data set that that won't train very well, but what happens is it'll try to run for 100 epochs, but as soon as the validation error doesn't improve for 4 consecutive times, it'll stop. So now we can see that a model, and the default name for the model is just the model plus the date plus the time. And now we want to move this model back to the car. So we can use SCP again in the other direction. We're going to get that model and we're going to move it to the Pi. And we're going to just put it in the Donkey2 directory. So now we have a model that is ready to drive with, and here we just specify that the model we're going to use is that model we just sent over. So here we're going to drive with the model, and this will take a little bit longer to start up because it's got to load that TensorFlow model. But once it does, we can load the web controller and then first use the auto angle to see that the steering actually works, and then if that works we can use the autopilot. Okay, so this is up. So now when we use the local angle, when you do this with actual driving data, you'll see your steering start to twitch because it's guessing which way to turn. When you put it on the track, you can then just use the throttle to drive, and it should steer itself. Then once you're confident with that, you can use local pilot, and the car will actually start driving right away. And remember that space or pressing the start-stop vehicle will stop your car. There's no need to chase your vehicle. All right, I think that's close to 5 minutes, and that's how to go from just having a Pi on your car and a computer to making an autopilot. Sweet, I hope this makes it easier for people to use the car and contribute. Thanks.